All right, let's talk about one of the biggest, most important upgrades to AI that's happening right now. It's a technique called Retrieval-Augmented Generation, or RAG for short, and it is completely changing the game, turning our powerful, but let's be honest, sometimes flaky AI models into assistants you can actually trust. So yeah, let's get right into it. I'm sure you've been there, right? You ask a chatbot what you think is a pretty simple question, and it comes back with an answer that sounds super confident, totally plausible, but is just completely made up. It's a classic AI problem, and it's a huge one. These weird answers, these hallucinations, are really just one symptom of a much bigger issue. You see, large language models are basically working from a closed book memory. All their knowledge is just frozen in time from whenever they were last trained, which means you get outdated answers. They can make up facts, spit out generic responses, and there are some serious privacy issues with how they handle data. So the big question is, how do you fix all this? Well, this brings us to a really elegant, really powerful idea. Instead of asking an AI to basically memorize the entire internet and get everything perfect from memory, what if we just changed the rules of the game? What if we gave it an open book test? What if we could just hand it the cheat sheet it needs right when it needs it? That simple idea, right there, is the whole foundation of RAG. So yeah, this open book approach is officially called Retrieval-Augmented Generation, or RAG. It's a system that bolts a standard AI onto an external private knowledge base. Now, that could be anything: your company's internal documents, the latest scientific journals, up-to-the-minute financial reports. The point is, the AI gets to look up the facts before it even tries to answer you. Okay, so how does this open book test actually work behind the scenes? Well, it's a pretty clever four-step process called the RAG pipeline. Let's break down exactly how the AI gets its hands on those notes. First up is ingestion. The system takes all your source documents, we're talking PDFs, web pages, you name it, and it chops them up into smaller, more digestible chunks. And then, here's where the magic really starts. It converts every single one of those chunks into a special numerical format called an embedding. So what on earth are these embeddings? Honestly, you can think of them like a universal language for ideas. A vector embedding turns any piece of information into a long string of numbers, kind of like a numerical fingerprint. And the truly key part is that things with similar meanings get very similar fingerprints. So the numbers for king end up being really close to the numbers for queen, and dog is right there next to puppy. It's all about meaning. And this process is just incredibly flexible. I mean, look at this. We can take audio, text, images, even video clips, and run each of them through a special model to turn them all into that same shared numerical language. And that is what lets an AI search for a single concept across a ton of different kinds of information, all at the same time. Okay, on to step 2, retrieval. So when you ask a question, the system does the exact same thing to your query. It turns it into a numerical fingerprint, an embedding. Then it zips through that entire database of document embeddings, looking for the ones that are numerically the closest, the ones that are the most similar in meaning to your question. This isn't your old-school keyword search. This is a search for concepts. And now for the big finish, the last 2 steps. In augmentation, the system takes your original question and it stuffs the prompt full of all that relevant information it just found. This brand new supercharged prompt is then handed over to the LLM for the final generation. Now, with your question and the perfect nodes sitting right in front of it, the AI can generate an answer that's actually accurate, specific, and grounded in real-world facts. Okay, so that's the technical side of it. It's cool, it's clever. But what does this actually mean for us, in the real world? Where is this stuff actually making a difference today? This quote just hits the nail on the head. We've all felt that pain, right? You go to a customer support site, you type in your problem, and you just get back a useless list of links. RAG is what fixes that. Instead of a search bar, you get a helpful assistant that just gives you a straight answer, an answer it created from the company's actual support documents. And believe me, it goes way beyond just customer service. RAG is transforming whole industries. For lawyers, it's slashing research time by finding obscure case precedents in seconds. In healthcare, it can combine a patient's history with the latest medical research to help with diagnostics. In finance, it's a no-brainer. It pulls in the absolute latest market data for its insights. It's even changing how we work, letting any employee just chat with their company's entire massive knowledge base. So RAG gives the AI access to the right information. That solves the whole hallucination problem, right? Well, mostly. But it brings up a new, much trickier question. how do we actually know if the answers are any good? How do we measure the quality and make sure the system is working the way it should? When it comes to evaluating these RAG systems, it really boils down to two main approaches. The first one is called ground truth-based. That's where you compare the AI's answer to a perfect, gold standard answer that a human already wrote. The second is reference-free, where you don't have a perfect answer. So instead, you use another powerful AI to act as a judge and score the first AI's response. And this, right here, is where things get really fascinating. When researchers actually compared these automatic evaluation scores to what real humans thought was a good answer, well, the results were like night and day. The ground truth method, the one with the answer key, it actually matched human judgment pretty well. But the reference-free method, where one AI judges another, the correlation was almost zero. It turns out AIs are still really bad at grading each other's homework without a cheat sheet. So the takeaway here is pretty clear. RAG is a massive, massive leap forward. It gives AI the incredible superpower of looking things up, which makes it way more factual and useful. But our ability to automatically check its work and verify the quality of its answers, that's still got a lot of catching up to. This technology is really poised to unlock these enormous, siloed stores of human knowledge, everything from ancient medical archives to our own personal notes. And that leaves us with a pretty cool question to think about. As we start giving AI an open book for every test it takes, what's the very first book you'd want it to read?